studying rational exponents. This is something we've done. We're just adding variables, letters. Okay. So we can start out with rewrite that as a radical.
They could tell you.
Yeah. So what's the radical there? The fifth root of 4, right? The denominator goes in the root. And then the 1, of course, is 4 to the 1. We don't have to write it. The only thing we're adding today is a letter. So what's that one become?
A.
What roots? Fourth root of A. Okay. So that you guys, if you've learned this, it's going over. We're adding variables now. Okay. So you can write those both ways. You can calculate. And this would be rewrite. 243 like this. 33, okay. You can calculate those, right? Yeah. Okay, what's method 1? Use a calculator, right?
Yeah.
You could rewrite it and do it. Eventually, you're going to end up at a calculator for this one, because it's a big number.
What's the exponent on that first root or the 5?
5. So, can somebody do this for us in a calculator? Remember that you just type it in. And hit enter.
I just put 5 in there.
Yeah, you could also do 5 x root 243 to the 3rd. Lots of ways to write this problem out in your calculators. Okay? Use whichever one you prefer. So are we good with that? You can have some practice there. The big part of today, we finished writing.
I was on the last one.
Okay, no worries. I'm kind of going fast.
Yeah.
I know you're slow, so I'll slow it.
Yeah, exactly. And 243. Okay, we're ready.
Hold on.
Good. Okay, what did you do with that situation to simplify it? Add the exponents. Because the bases are the same, you can just add the exponents, right?
Oscar Lanza, Mason Lerman, Micah Lockett, Kylie Miller, Brandon Milliams to the office.
Oh, this is the guy. Did they get checked out?
Right, helps. Now,
150.
we're going to put fractions in.
No, I don't think
So
so.
you know how to do the math for fractions, you know how to deal with the exponents, you're combining those, okay?
I don't think you know how to do that.
So, same base, right?
Oh, the same
Add the
denominator.
exponents.
Then just add the top. No. Put in the same
So,
denominator.
yeah, this one's easy because the base is the same, the denominator is the same,
Your favorite side, which is 1.
and you're good to go.
Can you give us like a quick lesson on how to add it? They don't have the same denominator. Yeah. Oh, yeah, you get the same denominator.
Okay.
So you times 1 by 2, or you times both by 2. Oh, no.
A common denominator, which is gonna be what? 6? Agree? Agreed? 6? So how do I rewrite this? In sixths. Yes, we have a times 3 here and a times 3 here. And a times 2 and a times 2, right? And that gives us, okay? What if I throw something like this at you? So remember here, you're gonna have the addition and subtraction, the multiplication, and the exponents, right? If it's divide, it means, so if I, let me just make sure. That's not. What do we do with the exponents there? Anybody? You didn't say multiply? So you multiplied and added, what is dividing? Subtract, yeah. And we have to have a common denominator, right? So I change the 1/2 to 3/4. Subtract. Bam.
Is that F?
Yeah, it's an S.
Mm-hmm. The only thing I don't understand is like, after you get to like, you're on the second part where not the division, but you have the 1/2 minus 1/4, and then right after that, how did you get the 2 for the numerator?
Okay, this, the common denominator needs to be 4. You
Yeah.
agree?
I
Okay.
understand that.
So 2 times 2 is 4. So 1 times 2. You get the numerator. You multiply by the same number top and bottom. Okay. So here we needed 6. So 2 times 3, 6. 1 times 3. Okay, what do I do with the exponent to an exponent?
I can't even read that.
You want me to rewrite it?
Please, it's you.
T to the 1/2 cubed.
Then you put that exponent up. Right, so when you multiply times the
Multiply. 3 times 1/2. Yeah. Oh, yeah, right, it's a fraction. Either way. The last one that we did What do you do at the negative? Yeah, you put it on the bottom. Remember that. You're gonna use it too.
Good.
Here's some of the harder problems you might run up against. Probably not. Yeah, I know you can type this in the calculator. Yeah, when it says simplify, it means don't just give us a decimal.
Okay, would you simplify, would you get rid of the roots first?
Okay, so we're gonna rewrite it.
So 8 over 81, 8 over 1, and then still calculate 3 to 6 over 1. So 1 over 8. Oh, then you minus the things, you get the same.
Not yet. The bases aren't the same. And you make the bases the same.
Yeah.
These two numbers?
6 and 8, and 9, 6.
No, these two numbers.
81. Oh, I don't know.
Have to match for us to subtract. Is there a way to write 81 as 3 to some power?
Yeah, you probably would. I don't know, I think.
Try 3 to the second, 3 to the third, 3 to the fourth.
3 times 3 is 9 times 3 plus 30.
3 to the fourth.
Times 3.
Okay, that's going to be the trickiest part of this, is getting the base the same. Then I can multiply those two, right? What's 1/8 times 4? 4/8.
Okay,
So 1/2.
Yeah, 1/2. Okay. Okay, now I need a common denominator so I can subtract, right? I'm probably not going to do this problem.
12. I'll denominate.
6, right?
6 over.
Okay.
Yeah. 6 over 6 minus 2.
Lots of equal signs.
Oh, you can just multiply one down there. I just put that way. I thought you had to multiply by 4.
Yeah. 2 times 3? 1 times 3.
No, that's the numerator denominator. I thought you may have to multiply both of the denominators to get one common.
No, not necessarily.
You could just do one.
If you're able to make 6 out of this, you don't have to change this one. Don't change it. You don't have to. Yeah, there's a lot going on there. You know all the steps. You just gotta put them all together. Okay? For you it is, Lash.
Oh, I'll forget.
Okay, so the key here, 81, you understand writing is 3 to the 4th.
It's gonna be in 10, right?
Maybe, if it's on the review. Oh, it's 15 over 12. That one just is a flat calculator problem. So change them to the same base. Then simplify that to the
fractions, you can see the simplified fractions. And you don't even need to subtract, so you need a common denominator, and then it comes to the end. There's really only three things you've done here. Made the same base. You've multiplied the exponents here. And then you subtract.
Thomas Moore, Magenta Moreno, Obed Uniton, Fernando Munoz, and Karina Munoz.
Sorry, that didn't sound very good, did it? Oh, yeah, there you go. I don't do a very good woman words. Some people I can do. Let's see. Every single thing they give you an equation is the same. The equation is okay. Okay, let's look at one more and then we'll be done. My head hurts, really. Would you like me to help you with that? Your head hurts. Would you like me to help you with that? I can make it to where it doesn't hurt anymore. That would probably help. I can help too. I'm just telling you. You don't want to help? All right. Well, all I was going to do is hit him with a 2x4 and knock him out so he couldn't feel the pain. Yeah. Hey, focus here is our last one if you focus. If not, I'll just keep on talking. No, it's stuck. Okay. Last here. See how I rewrote 9 as 3 squared. You have to recognize those perfect squares. And then I wrote it as 1/4. Bro.
Wait a minute. What is Z?
Yeah. 3 squared, Z squared.
Yeah.
Um,
You just multiply it, so you get 1, 3, 1/2, and Z.
Yep, so multiply it in. 3 to the 1/2, Z to the 1/2. What's 1/2 is the square root, right? What? The 1/2 exponents? The square root?
Yeah.
You just simplified that expression. So I admit these are kind of funny. You guys might use the word useless. Give them a shot. If you can't get it, we'll keep practicing it.
Oh, number 2.
No, we skipped it.
Everybody at the
So Friday we just did practice, right? I skipped 5.6. In order to do the test this Friday, so you don't forget everything on the same shape and right? Is that okay? Plus we remember. Yep. They're not that, but they're short problems. Okay, this is good one. Do tomorrow.
Thanks,